Section 3.3, we're going to be taking a look at our last type of compound sentence, compound statement, which is called the conditional. If you remember, the conditional was the ones that we mentioned last time that are if-then statements. So conditionals have that form, if-then, and the notation that we mentioned but didn't really do anything with last time is that it's an arrow. So you have a P, arrow, Q, and sometimes we read this as P implies Q. The P part has a couple of different names. It's called the antecedent. It's also called the premise. And what comes afterwards, the Q, is called the consequent or the conclusion. So I'm going to give you an example of one that we're going to use in a little bit for describing more of what's going on. If my daughter does not come home soon, then I will call her. This would be a conditional. My daughter does not come home soon would be the antecedent, and I will call her would be the conclusion or the consequent. Okay, so we're going to do a couple of examples. Whoops, didn't mean to do that. Let's do that. We're going to rewrite these statements in an if-then form. So in English, we reorder things a lot and don't actually change meanings of things. And if-then statements, conditional statements, is a really good example of when this happens. And so these two are not written in if-then form, but they are conditionals. So we're going to put them in that if-then form because it will help us, in particular later on, to make decisions about when statements are valid or invalid. Okay? So this says it must be breathing if it's alive. And what I want you to see is that the if is occurring in the middle of the statement, right? It's a little bit awkward in the way that it's written, but the if part is the beginning part of this statement, right? It's the premise. It's the hypothesis, right? It's the beginning part. So this is where we're actually going to start with our rewriting, and we're going to write that first. If it is breathing, and then we're going to go back to the beginning, which is actually the consequent, then it must be alive. Those two statements are exactly the same statement. They're ordered differently. Notice the if stays connected to the same thing it was connected to. I didn't just move the if to the beginning. I moved everything that the if was connected to the beginning. Okay, that's really important. All right, the next one doesn't seem to have an if in it at all. It says a shopaholic has no self-control. Okay, so what is this saying? Well, if I'm going to write this in if-then form, and we will need to do this with examples just like this later in both 3.5 and 3.6, we need to have our if at the beginning. And then you can use whatever noun or pronoun you kind of like to next. If he, she, they, it, I don't care what you use. I'm going to use she. If she is a shopaholic, then, same pronoun or same noun, she has no self-control. Can you see how that sentence is the same as the one that we started with? Except for the fact that I gave it a she as the person. You could put somebody's name in there too, yeah.
How do you, like for that one, since there's not an if in it, that like decide that it's not, if she has no self-control, then she's a shopaholic?
So we're not going to reorder unless the if is already connected to something in the wrong location. That's a good question. Okay, did everybody hear a question about that? Okay, so we're not going to reorder like we did in the last one. Right? Change the order things around unless the if is occurring in the middle. And there's actually a caveat to that too. We'll see that in a little bit. But in general, right now, that's enough for us to go with, okay? Okay. What we're going to do next is we're going to do like we did last time. We're going to start with symbols and we're going to write the words. And then we're going to take words and we're going to go back and write symbols. Okay? So we have a couple of descriptive phrases here, statements. We've got S is she has a ferret for a pet. We have P is he trains dogs. And then we have M is they raise alpacas. All of you who are pet lovers, right? This is my 10-year-old. I guarantee you she's going to do something with animals as a career. I don't know what it's going to be. It just may be filling her house with them. I'm not sure. She loves her animals, okay? So we're going to do an if-then statement. So there's an arrow here. That's how I know I'm going to do an if-then statement. The if occurs at the beginning before whatever P, in this case, because that's the beginning part, represents. So I'm starting with if. What does the statement that goes along with P say? He trains dogs. So we're going to start with if he trains dogs. When we come to the arrow, that's where the then goes in. Then. Now it says tilde M. What is M? They raise alpacas. So what would tilde M be? They don't. Remember, the tilde means negations, the opposite of. So this would be then they don't raise alpacas. Okay, is that all right? So I believe we're going to go the other direction now. It's the same parts at the beginning, so none of that changed. This one now has more going on in the sentence than the last one did in the statement form with the symbols. So I'm going to go and identify a few pieces in here that are important. I've got the if and I've got the then. So those two pieces right there, I'll circle them, are my connective pieces. And I want to see the pieces that they're connecting in between. So this one says he does not train dogs. That's fine. This one says she has a ferret for a pet. But then I actually have the word or here. And they raise alpacas. So not only is there an if-then in this one, there's also an or in this one, okay? All right, so it starts out in if. So we'll start out with the first part of the statement, whatever letter represents. So what is the letter is he does not, what is the letter representing he does not train dogs? P, and then because it says not, it would be tilde P. Good. Tilde P. We encountered the word then next. So we're going to do our arrow. After that, the consequent or the conclusion is all the pieces that follow. All right, both of the pieces with the or. So I'm going to put it in parentheses to indicate that. I do not believe there's anything inside of your My Math Lab homework that makes you feel like if I don't do the parentheses, I'm going to make a mistake, or they're going to put one where it does and it doesn't have it. So don't get too caught up with the parenthesis part here, okay? It's just not, that's not the focus here. The next part, however, says she has a ferret for a pet. How do I represent that? That was S. And then I crossed through the word or, that's circled. How do I get the word or in symbols? It was a V, good. That was last time's. And then it says they raise alpacas. That was M. Okay, we're just reading it piece by piece and putting in the symbols that represent them. Okay, the next thing that we're going to do is we're going to create a truth table for a conditional statement. And I'm going to move this over here as our conditional statement to be under consideration as we're doing this. That's not the one that I wanted. This is the one that I wanted. All right, I don't need necessarily the yellow parts, but that's okay. We can have them. All right, so just like the other truth tables that we created, we're going to create them for two statements, P, Q, and then in this one we're doing is the conditional, so P implies Q. The first two columns are always the same. Tell me what the first column is. True, true, false, false. I almost don't have enough space here. How about Q? True, false, true, false. right? I think, and you will agree after we've done it, that this is the most confusing truth table, right? It just is. So we're going to take a look at what happens when these statements are true and false, respectively, whatever they are for the P's and the Q's. So what I have going on right here is that the first one is highlighted in yellow as P. Let me change the coloring for this one so I can reference it by color. And the yellow one is going to be Q. Okay? So it says, if my daughter does not come home soon, then I will call her. All right, so just like with all of our other truth tables, when we have a true statement, it's going to be a true conclusion. Okay, that's always going to happen. So true with and, true with or, true with if, then they're all truths. So a whole lot of truths going on, you got something that's true. But let's talk about real quick why. So this is saying my daughter does not come home, right? That's the true statement. That truly does happen. Then I will call her. That would be a true statement, and all of that putting it together is exactly what that statement said to begin with. So this is a true statement. So then, given this statement, if my daughter does not come home and I don't call her, that's false, because that's not what the statement said I was going to do, right? She did not come home soon and I didn't call her. Well, that's the exact opposite of what this statement says. So this would be a false statement. For the most part, those are usually okay with everybody. It's the next two that make us feel a little bit, I don't know, like we're getting the wool pulled over our eyes or something. That's what it feels like. The reason is because the premise starts out false. Now, this premise has the word not in it, and I tried to come up with something else that didn't have it. Not everything I could think of still had the word not in it that made it work in my mind for a good example. So we're just going to have to deal with it. This statement says, if my daughter does not come home soon. So if that's a false statement, it means she did come home soon, correct? Okay, so these last two lines are the daughter coming home soon. The problem is that if the daughter comes home soon, I still may or may not call her. I have no way of knowing what will happen because the premise wasn't satisfied to begin with, right? Another example I was thinking of, so I have a daughter that likes to leave her shoes on the floor, one of them. I have other kids that do other things, but that was the one I thought of first. Shoes on the floor all the time. So if she leaves her shoes on the floor too often, my husband will take them, or I will, and she doesn't get them back for a few days. I mean, this is supposed to be teaching a lesson, but we redo this process all the time. And so, right, so if she leaves her shoes on the floor, then mom and dad takes her shoes, right? But the problem is that if she doesn't leave her shoes on the floor, right, if they're somewhere else, there's no way of knowing what will happen next. Maybe mom and dad still take her shoes, right? Maybe they're muddy and they need to be washed. I don't know. Maybe mom and dad don't take her shoes. So what happens is that these last two statements, when they start out with a false premise at the beginning, either of those options at the end are perfectly valid and can happen. The daughter does come home soon in this example. I still may call her, right? She's upstairs, I'm downstairs, I don't want to walk up the stairs. Y'all know what that's like, right? Maybe not. Or maybe I just don't, right? Because now she's in the house with me and I can just talk to her, so there's no reason to. But there's no way of saying that for sure the statement is actually a false statement. So by default, what happens is we say that these statements are both true. At least they could be. Okay? So that's why those will stay true. And it feels a little funny. But if the premise is false to start with, I have no way of deciding that the conclusion will be true or false. So the statement itself can be true. All right. So like last time, we're going to create some truth value ones. So these truth value ones are ones where they tell us what P, in this case they're using P, Q, and R, what P, Q, and R are, as in are they true or are they false, and then we're going to make a claim after that as to whether the statement itself compiled together is going to be a true or false statement. So in particular, what you see is P and R are false, right? And Q is true. So the first one here doesn't have a Q in it, so I don't necessarily need to put the Q in my table. If you did, it wouldn't hurt anything. But because the R is listed as the antecedent, right, the part at the beginning, I'm going to list the R first. I'll do that. And I'm going to list the tilde R next, just because it comes at the beginning. It'll help us because there's direction to this arrow, when we did this back in the last section, there was no direction. It didn't matter if the and had the P first and the Q second or the Q first and the P. It didn't matter. Here, because there's direction on the if then, it's easier to see the part at the beginning. So I'm going to write it that way. And then I have a P at the end, the consequent. So like this. And then I have all the individual pieces so I can put it together. So this is tilde R implies P. Okay, are the column headers okay? I realize that the ordering looks a little funny compared to the things we did last time, but are the column headers okay? All right, what is R according to the pieces that I was given in the directions? It's false, which makes tilde R true. What is P? False. Okay, now we're ready to put them together. So we're taking the arrow going like this, right? So I have a true implies false situation. And when we just did the truth table above this, true implies false is false. So this one's false and the truth value is false. Okay, let's do another one. This one has all of them, P, Q, and R. The part of the beginning again has the tilde on it. So if you want to kind of go out of order and do that part first, it kind of makes sense to do so. So I'm going to do P, and then I'm going to do a tilde P like that. You wouldn't have to do it in this order. There's going to be some later that I'm not going to do this order, so you can see what that looks like too. The individual pieces in the parentheses involve both a Q and an R, and then joining them as Q and R. And then the last part at the end puts it all together, which has tilde P implies Q and R. So the ordering of this is a little bit of arbitrariness, right? I could have done P, Q, R, and then done the tilde P, and then done the Q and R. That'd been fine too. As long as they're all in there, you'll be able to work with it after that. So what is P? False. So what would tilde P be? True. What is Q? True. What is R? False. Okay, so those are the individual ones. The individual statements are usually pretty quick to take care of. The next one actually has an and statement, right? And it wants me to join Q and R together. So Q is this one, and R is this one, and it's an and statement. So what is true and false? And. That's false. We did that one last time, right? So this one's a false statement right here. And then it wants me to do an if-then statement, and they're kind of separated on my table. So I'm going to draw arrows over it just to remind us where we're starting and where we're ending. So we're starting here with tilde P, and we're ending with Q and R. So it's going over like this, right? So from the bottom's perspective, we're going true from the far left to false. So what is a true false statement's truth value? It's false. I promise they don't all end up false. Just these two did. So far, so good? Okay. A little bit of vocab next. A tautology. A tautology is a statement that is true no matter what the truth values are. And the way we can identify it from a table's perspective is that the final column of a truth table, which we've never seen this happen as of yet, by the way, but the final column of the truth table all has true in it. It goes true, 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 all the way down. And when and if that happens, that's called a tautology. Okay, example number 7 has two statements, P and Q. right? So it's just like the truth tables I've been working with the majority of the time. I've only had one truth table, and that was last time where we had 3 statements. We'll have another one here in a minute to practice with 2, but this one just has 2. So it's the smaller style truth tables that we were doing the majority of the time last time. I need a column for P and a column for Q. And then I want to start inside the parentheses for a couple of reasons. Number one, there is an inside of the parentheses to start with, but also because it's the end, the premise, right? It starts at the beginning. So it makes sense to start there as well in terms of like listing everything out. Now inside that parentheses, I am missing one of those individual components. What am I missing right now? Tilde P. So I need a tilde P in order to proceed. So I'll have a tilde P here. And then I'm going to combine everything that's on the inside of that parenthesis, which is an implication itself, or a conditional. So I have a tilde P implies Q. That's everything inside the parentheses. And then I need one more piece here at the end. The last piece is going to include everything from the inside of the parentheses, and then the arrow and the conclusion of the entire statement. So it's going to include tilde P implies Q, that's the previous column, and then implies Q again. And again, I know it looks like just a lot of T's and F's going on and there's no context with what we're doing. We will get there. We're just trying to get down the idea of how to work with them before we do, okay? We will get there. All right, you know what column P looks like. What does column P say? True, true, false, false. Good. What does column Q say? True, false, true, false. You can always do that in your tables, yeah? How about tilde P? What will that be? Good. So that reverses column P. And I have the first time now where we're going to go backwards. So I'm going to go this direction from tilde P back to Q. I told you I would show you one at some point that I was going to go backwards so you can see that it works. You just have to be careful on how you're thinking about it. So in this column, I'm actually starting off the first 2 statements with a false statement. Those are the weird ones on the implications, right? When it starts out false, it's automatically true. Where was it? I went too far. This one. It's the last 2 lines of the truth table. If it starts out false, no matter what comes next, I get a true statement at the end. So false, true is true. And false, false is true. So the one that I'm on right now, that's where I am on lines 1 and 2. False, true on the first one and false, false on the second one. Both of those are true statements. The next one is a true, true. So when true implies true, that's true. Those are the ones that are always true no matter what type of a compound statement we're working with. And then the last one is true implies false. That one's the false one. All right. Next, we're going to take the one we just created, the tilde P implies Q. And we're going to go back again to row Q this time over here. So we're going like this. Tilde P implies Q again. So on line 1, I have true implies true. That's true. Line 2 is true implies false. That's false. Line 3 is true implies true. That's true. And line 4 is false implies false. That's true. Okay, started out false, it's automatically true. And what we're trying to do after we just create the truth table, which is part of the directions, is to decide, is it a tautology? Okay, and the answer is no. How come? I don't have all true statements in the final column. So this one is not a tautology. So what does this look like in my math lab? Well, it looks like you're creating the truth table, and it looks like you choosing from a multiple choice statement at the end that says it either is or isn't a tautology. So clearly, if you make a mistake in the truth table, it might affect the final answer of whether it's a tautology or not. And again, this would be a place where I would go and give partial credit if you ended up getting all truths at the end, but you shouldn't have. So you said it was a tautology, but it really wasn't. You know what I'm saying? So be aware. All right. Next one has 3 statements, right? P, Q, and R. So this one's going to be one of our larger truth tables. I don't think it'd be quite that big. That's probably sufficient. Okay. So I'm going to go P, Q, R in my ordering, and I'm going to just go back and forth as needed on the table, okay? If you really don't want to do that, that's fine. You can do the P and the Q first, which, or the R first, whatever. But you can actually make the part in the parentheses come for sure after the R part by design, if it doesn't do so naturally. I think this one might do so naturally. Let's see what happens. So I'm going to do P, Q, and R. Those are my individual statements that are here. And if I start inside the parentheses, I'm going to have a tilde Q, correct? Yeah, so I need a tilde Q. And then, again, working inside the parentheses, I'm going to join P and tilde Q together. And then if I work from the outside of the parentheses in, I already have the R that's on the left. Yeah? So that's good. I don't need to add anything to it. I just need to combine everything that follows. And this one actually, by the very nature of the way it's written, does have R coming before it. So the order going from left to right will be a little bit easier to process for us. Okay? So we only did one of these last time, so we'll see what you remember. What does column P look like? Close. It's 4 trues and 4 falses. Yeah, so 4 and 4. 4 trues, 1, 2, 3, and 4. 4 falses, 1, 2, 3, and 4. What does row Q look like? Good. So they oscillate true, true, false, false, true, true, false, false. What does R do? True, false, back and forth, right? Okay, next we have tilde Q. What's tilde Q going to look like? Good, false, false, true, true. False, false, true, true. And now we're going to do some combining of some columns. So this one says I'm going to combine columns, P, that's buried back at the beginning, and tilde Q, the one we just created. And I'm combining them with what kind of a connective? And. When is an and statement true? When they're both true. So we're going to go one line at a time. The first one says true, false. Second one is true, false. Third one and fourth one are both true, true. So those are true. And then the last 4 lines are all false. Right? They start false. I see them in the P column. The P column's false. It's an and statement. So all of the last 4 are false. Remember, and statements are the simplest ones to make the decisions about quickly, right? Okay, next we're going to do the implication. This one's actually an implication piece. And we're going to take the R column and we're going to move it over to the P and tilde Q column. So we're moving this direction. It's an if then. So line by line, the first one is true implies false. That's false. Line 2 is false implies false. That's true. Line 3 is true implies true. Line 4 is false implies true. True. Line 5 is true implies false, even if I'm a little disconnected, yeah. Line 6 is false implies false. Line 7 is true implies false. And line 8 is false implies false. Is this a tautology? No. Not a tautology. Okay. So one of the things that we worked with in the last section at the very end were something called De Morgan's laws. Do you remember that? They talked about what we do when we negate and or statements. And what we did is we negated all three pieces. So whatever the first piece was, we negated it. We negated whether it was and or it's or, and then we negated what the second piece said. So what we're going to look at next is what we do when we are writing negations for conditionals. So if I have the negation of a conditional P implies Q, the negation is P and tilde Q. That's the negation. And I'd like to give you an example that we've already used. If my daughter does not come home soon, then I will call her to show you why it works. So do you remember the only line in the truth table that shows up false? The true at the beginning and the false at the end, right? That's what this is. The first part's true, P. The last part's false, making it the opposite. That's the tilde Q. And I'm joining it with and. This is exactly the statement that my daughter does not come home soon and I still don't call. That is the opposite of what I just said I was to do. It's the negation. Okay? So you leave the first piece the same. It becomes an and statement and you negate the second piece. So we're going to look at an example here and we're going to do this. I don't have it written in exactly the right form, but it's really close. It says, if Ella reaches that note, she will shatter the glass. I'm kind of missing the word then, so feel free to put it in right here if that's helpful. There are two individual statements. Ella reaches that note, and she will shatter the glass. And they are connected with the if-then at the beginning and the middle. So the negation is, we leave the first part the same. We don't write ifs and thens anymore. Notice that, right? This is an and statement now, so there's no ifs and there's no thens. Sometimes the language has to change a little bit to make it make sense in terms of the way we structure English. This one's not too much so. But instead of it saying if Ella reaches that note, we simply say she does. Ella reaches that note. Then we put the word and we negate the second part. What will the negated version of the second part look like? She will not shatter the glass. Now, that said, you could change verb tenses and it would be okay too. She did not shatter the glass. That would be all right, sort of from a past tense perspective, and that would not cause any problems. Okay? So there's also a way that we can take an if-then statement and we can rewrite it as an or statement. So if we have an if-then statement, P implies Q, this is equivalent to, right, it's the same as writing tilde P or Q. We negate the first part, we make it an or statement, and we leave the second part the same. This corresponds to the three truth outcomes on my truth table. Okay, let's look back real quick at that example over here with the original truth table. So the first part is negated, daughter does not come home soon, turns into the daughter did come home soon, right? The daughter did come home soon. Or, so she either did, or, because I turned it into an or statement, and then I leave the second part the same, or I will call her. That's all three of the other lines on my truth table. Okay? We're going to take this statement and we're going to rewrite it. It's kind of a funny one because it's so generic-y. If she doesn't, he will. I don't know what she and he are doing, but something, right? I don't know. If she doesn't erase the board, then he will. I don't know. Looking at my boards. I don't need to erase the boards, but whatever. There is a then here that's assumed, right? All right, so we're going to negate the first piece. The first piece says she doesn't. What's the negation of she doesn't? She does. What will I put next? Or, and then I need to leave the second piece the same. He will. She does or he will. And that means the same thing. If she doesn't, he will. Well, she either did, and so there's no need, or he did. One of the two happened in that case.